Namaskar from our channel Engineering Dynamics, the Consultant's View. Today's technical session is on rehabilitation of steel I-beam used for roofing structure. The concept of roof was known very early in the history of humanity. The prehistoric hunters and gatherers retreat into caves. The oldest roof was supposedly made of the skin of a woolly mammoth in Siberia around 42,000 years ago. The evolution of roofing reflects the ingenuity and adaptability of human civilization. Roofing has evolved significantly over the centuries. From the ancient roofing techniques used stone and slate as roofing materials, the evolution passed through usage of medieval roofing materials like clay and wood as base material, industrial revolution on roofing using metal and asphalt, modern roofing innovations with diverse composite materials, and finally, today's sustainable roofing solution targeting to reduce waste, carbon footprint, long-term economy, and energy efficiency. For old buildings, mainly for residential units, flat tiled roofing supported by steel beam was very common. Nowadays, RCC replaced it, though cement manufacturing in India started during First World War in 1914. Its use gained popularity after Second World War with adoption of cement expansion scheme by the government in 1948. Tiles made of clay were used to be the roofing material and base for flooring. These tiles were supported on wooden battens, usually act as cross beam, and these battens were supported on steel I section, act as main beam, which transferred the load on the masonry walls. Hence, the roofing elements are steel I beam, wooden batten cross beam, and clay tiles as panel roofing materials. The residential buildings constructed in the first half of 20th century are now about 100 years old and under serious pressure of thorough maintenance and rehabilitation. Considering the roofing elements, the most common problem noticed is corrosion of steel beam. Interesting fact is that it normally starts from the bottom flange where it is rested on masonry wall. The other noticeable issues are termite attack on wooden battens and cracks on tile joints. It is a legacy burden on the next generations. Those living in their ancestral property are bound to experience it. They have to do maintenance activities but on the exposed surface. But what about the portion of the components which cannot be seen and are concealed inside the wall? If we carefully notice, the corrosion in beam occurs in the portion inside the masonry wall. Corrosion starts from bottom flange at the inner face of the wall and propagates inside the wall. It makes the main beam vulnerable and shows a tendency of shear failure. It is very risky and predicting of such failure is practically impossible. The only way one can handle this is through reactive approach. Is there any positive approach? Today's video will focus on rehabilitation of steel I section old beam through proactive approach. This problem is very common, hence its solution has also been a common one since last 50 years. Put a small beam section element as bearing block inside the wall to support the main beam. The existing old main beam will rest on the overhang portion of the bearing block element. This small bearing block may be of wood, stone, RCC and steel section. The block is cut to shape and size or prepared at site and inserted inside the wall below the old steel I-beam in such a way that the existing I-beam can be rested on the bearing block. Wooden block is costlier and prone to termite attack. Stone and RCC blocks of required size are heavy to fix near the soffit location. Easier one is to fix steel member. Also, from design point of view, it is evident that size and weight of steel elements as supporting block is much less than others. Though the bearing block shall be capable enough to resist compressive strength, the overhang portion requires to have tensile strength in bending. Wood and stone have low tensile strength. RCC and steel blocks are suitable from structural point of view. Bearing block is fine for supporting the main beam. What about future corrosion issue? We know the reactive approach. Can we think any sustainable proactive approach? Let's improvise in fabricating the steel bearing block. Here, the solution is, which is being implemented in an old residential building. The clear span of the beam is about 3 meters. A thin steel plate is welded at the bottom side of the steel block at a defined configuration. Reason, I will come soon. A composite block is fabricated. It also enhances the bearing area of the block on the wall. The composite is painted thoroughly with primer to reduce corrosion effect. This modified block is now made ready for erection. Overall size is 28 mm thick, 220 mm width and 400 mm depth. Here depth means inside the wall. The existing beam which needs rehabilitation is firmly supported with bamboos. Adequate bracings are provided to reduce lateral buckling. Bamboo support shall be 450 to 600 mm from the wall. It will allow the mason and erector or welder to work at the location. Masonry brick wall is then chiseled out at existing beam portion all around the existing I-beam to make a hole. Size is adequate for a mason to extend his arms and tools to fix the block and grout thereafter. For a I-beam of 200 mm height, the hole size shall be at least 300 mm width and 350 mm height. The steel bearing block is erected by temporary tying by tack welding with the existing I-beam bottom flange. It is positioned in such a precision that outer face of the thin steel plate will be just in line with the finished plastered surface of about 12 to 18 mm thick. The hole is then cleaned and made fit for placing bearing block. After positioning of the bearing block, the hole is then grouted with cement mortar. Later, the visual exposure of the thin bearing plate on the wall surface is covered by wall putty and paints. The reason behind is very traditional but not normally analyzed. It is interesting. When the composite structure will get prone to corrosion effect in future, the first point to get attacked will be the bottom side of the modified steel bearing block, that is this thin plate. It will expand in volume and make the surface paint to spoil off from the surface locally, and putty will show fine cracks on the wall surface. It will give an indication that corrosion has started. Immediately, preventive maintenance can be initiated. I think this simple improvisation on traditional method can bring proactiveness from maintenance point of view. Thank you for watching. Namaskar.